Hi everybody. I'm just going to make a short video for how to use the MultiSim to simulate simple DC circuit. That's the circuit in front of us. We want to simulate it, and I already opened MultiSim. All right, and I need like how many resistors? 4 resistors. Just I'll go there and by the mouse left click, get to the resistors from the list. Pick anyone, like this one is okay, just don't worry about it. Say okay. And you don't have to go and look for another value. Just, right click and make copy, and right click again and just make paste like um, 4 times to get the all 4 resistor. All right. R1 is 2 kilo ohm. It should be 5. So just right click and go properties, and you go for the value and just type 5. Okay, that's it. R2 is 2 kilo ohm. It's fine. R3 is 1 kilo ohm. Right click, properties, and type 1K. That's it. R4 is 1K. Again, right click. Oops. Should just yeah. When you click, you got to get this like dashed box around it, not only one value. And properties, and type 1K. Now we have the whole. We still need a battery. We need DC source 12 voltage. So I'll go again and click on the resistors. And if you cannot find source easily here, you just go for the list here, basic, and click on sources. And then you need ground to get the ground. Okay, that's the ground. And then you go DC power. You got here the battery. Okay, good. That's it. Close it. You have everything. All right, just try to arrange. This is your battery, and then you by the mouse, by left click on one terminal and connect the other. And you can click by the left and just by the arrow try to move it, squeeze a little bit. And R3, so just get this away, get R3 and connect here by the left. You press the left side of the mouse. Okay, and then click, and you can click to adjust it, and by the arrow up a little bit. All right, then you have R4 1 kilo. You get it here, drag it by the mouse, drag this far away a little bit, and right click and rotate 90 degree. Okay, and you connect this resistor. The last resistor here, get it in the middle, drag it, right click 90 degree, and by the mouse drag it. Okay, this one you can make a little bit, drag the mouse down and then stop, and then drag again to the left, stop, and then click and go up and connect. Okay, the last one, drag, click here by that. Okay, now it's completed. The circuit's fine. Now it's complete. Now, just let's say that you want to verify Kirchhoff voltage law. Kirchhoff voltage law, it means that you want to put voltmeter across R1, R3, R4. I'm checking Kirchhoff voltage law in this loop, the outside loop. All right. I'm not doing this. I'm doing this. I'm doing the big one outside. Of course, it'd be easy. Just I want to show you how you use. So where can you find your measurement tools or measuring instrument? You have here the first one. If you move your mouse here, you'll find this is a multimeter. So by the left click and then drag. You need the beautiful thing here, which is better than the lab. You can just have as many as you can from multimeters. So I make copy and and paste. That's the second one. Paste. Third one, because I'm going to apply voltmeter here, here, and of course the 12. It's known, but I mean, okay, I will do another voltmeter here. I'll paste one voltmeter here. All right. Now let's connect. I connect the first. You connect the positive to the positive, and connect the negative to the negative here. All right. The positive should be connected to this terminal, and the negative to the other terminal of the resistor. Oops. The third voltmeter, same thing. Okay, make sure that you get the red dot, make sure it's connected. And now we have 1, 2, 3, 4, and they are numbered here. This is number 1, number 2, number 3, and number 4. It's in the same sequence that I use. But you got to do something. This is a multimeter. You should adjust it voltmeter or ammeter or ohmmeter to measure the resistance. So you just double click by the left, and then you will find here AV ohm dB. Okay, we need voltmeter B. AC or DC, DC, click on DC. Okay, that's it, set. I'm sorry, that's okay. And then go drag this one here. Of course, there is no value because I didn't run the program yet. The second one, double click, voltmeter DC. All right, and double click, drag it here, adjust voltmeter DC. The last one, double click by the left. Okay, voltmeter DC. Okay, you are set. Now, you are set. You want to run the program, you just go for this one, run, or F5 as you like. So I just click, left click. Now it's running, and as you see, you got the voltage. So that's 12 voltage here across the battery, and you have that's V1, V2, V3 in the loop. You don't have anything else. 10 and 1 and 1. If you add 10 plus 1 is 11 plus 1 is 12. It's equal 12 here. So it's verified. So Kirchhoff's law is true. Okay. So let's just close this one, and you got to learn something. If you want to do any change, you cannot change now. Why? Because the program is running. You have to go and stop. Okay, now we can do the change. Well, I'm going to delete all these multimeters. I'll just leave one, and I'll show you now how you measure the current. But you have by the left click, delete, left click, delete. Now you got the connection away. How you measure the current? Let's say that you want to measure the current going through R1. So it's going from the battery R1. So you can break the circuit in this side or this side. I'll choose this side. So left click and delete. Now it's open. You bring the device here. The positive will be connected here, because the current going from the battery has to enter the positive of the multimeter to get positive measurement. So that's how we break the circuit and make the ammeter going in series. You got now to make the setting by left click. All right, and then you press A, DC. Now it's set. And you can even calculate the current. I can expect it, because you got 1 kilo ohm in series will be 2 kilo ohm. 2 kilo ohm in parallel with 2 kilo ohm, it will make 1 kilo ohm. 1 kilo ohm plus 5 will be 6 kilo ohm. So the total equivalent resistance of this circuit is 6 kilo ohm. If you divide 12 voltage by 6 kilo ohm, you got 2 milliampere. So let's say it's true or not. Run the program. It's really fun. We calculate and do it. Okay, 2 milliampere. That's right. Now stop. It's just like a nice game. I like it. When I was sitting, I love it. I was making many circuits and trying to design it and look at the. What about the current here, if you do you can estimate the current here, because this is, I mean, like 1 plus 1 is 2 kilo ohm and 2 kilo ohm, and you got 2 milliampere here. So the current will be divided equally, because this is 2 kilo ohm and this one is 2 kilo ohm. So be expect 1 milliampere. All right, let's make a copy and okay, copy, paste, and I will break here to measure the current. So I just left click here and then delete. Connect the positive terminal here to this one and this one. All right, now let's run. I expect this 1 milliampere. Run. Okay, 1 milliampere, because I mean this one belongs to this one and this one belongs to this one. So the total current 2 milliampere and the current here is 1 milliampere. So I think, I mean, if you just, it's very simple, nice, interesting software. So, I mean, if you just understood this one, you can, I think, do your lab MultiSim, this one, oncoming one. All right. Thank you and see you soon.